Good morning. All right. I am so excited you guys actually showed up. When I was looking at the schedule and I saw I had an 8:30 a.m. session the morning after replay, I was like, this is going to be super awkward talking to a crowd of 3 people. Hopefully they bring in extra AV folks so that it was more people there, but super excited you guys are here. Thank you so much for taking the time to come in this morning. Quick introduction, my name is Andy Reedy. I lead the Partner Solutions Architecture team at AWS, which is dedicated to VMware. So I've had the great fortune of being able to spend the last 3 years working with VMware as a partner and helping on designing and building and going to market with VMware Cloud on AWS. A quick logistical thing, my partner in crime this morning, Nick Ackel, had a conflict and was unfortunately unable to make it. So I thought about maybe trying to get like a jacket or something and pretend to be 2 people. I thought that would be really awkward, so did not do that. So we actually may run just a tad bit short this morning. I'll try to speak to some of his points the best I can, but what I had originally done was I was chatting with Nick about some of the things that I was seeing with customers doing with VMware and AWS integrations, and he's like, yeah, we do that. We do that. Everything I kept saying, he's like, yeah, we do that. And I was like, man, it would be totally amazing if you could come to reInvent and actually speak on stage with us, because I would love for customers to get a chance to hear from somebody who's actually done all of these different things and make it real. Give them the pitfalls, the challenges, the issues that you ran into, the pro tips, anything that you could share with them I think would be amazing. So we did this. He was able to join me on Wednesday. Unfortunately, he was not able to join me this morning, so I'll do my best to speak to that. I'm not going to try to throw my voice or anything crazy, so sorry, it'll just be pretty plain and boring. I've broken up this session into a couple different pieces, and this was really based on the feedback that I received last year. We normally do these VMware Cloud and AWS deep dives, and it was very focused on VMware Cloud and AWS. And the feedback we received last year was everybody wanted to hear more about native AWS service integrations. How do I integrate my VMware-based workloads with native AWS services? And there was really great feedback. So by the way, you'll hear me say it at the end of the session, but if you guys do get a chance to leave feedback, it's greatly appreciated, and it helps us tremendously. We actually all read this, and it helps change the sessions we do in future years. So please give us that feedback as we go through this. If we're missing the mark or there's something you'd like to see more, please share that with us. So the session today, the first half of the session, I really do want to focus on setting context on what is VMware Cloud on AWS. This is a huge tool to have in your toolbox to be able to leverage for hybrid cloud architectures. So I wanted to spend probably the first half of the session just really digging into VMware Cloud and AWS, setting that context. The second half of the session, we're going to focus on really integrating with native AWS services and actually give practical examples of what these things would look like. There's a couple themes, too, that I really want to make sure that we set here. One is that you can do a lot of these native AWS service integrations from your on-premises environments today. Most of the things I'm going to show you today can absolutely be done with your on-premises VMware workloads. You do not have to move to VMware Cloud on AWS to use a lot of these native service integrations. However, there are a lot of advantages and benefits that we'll go through of actually leveraging VMware Cloud if you're going to be integrating with these native AWS services, and I'll try to touch on those as we go through. All right, just to get started, I want to define, first of all, software-defined data center. This is going to be a key construct that we talk about today. For those of you who've worked with VMware, you're probably familiar with these components, but for those of you who are not, it really helps just to level set here on what we're talking about. If you hear me say SDDC, that's software-defined data center. So what is a software-defined data center? First and foremost, a software-defined data center is the virtualization of the components that you would typically have on premises. So this is using VMware software stack. So you think of things like ESXi. This is VMware's flagship hypervisor, the one that you've probably been using for 15 years now. But this is virtualizing the compute layer. Secondly, you have vSAN. vSAN is relatively new. It's been around for a few years. But this is virtualizing the storage components within VMware environments. And the way vSAN actually works is that it takes the local instance storage or the local storage within a physical server on premises, and it aggregates all of the local storage together to create a distributed data store. So if you can imagine if you had 10 terabytes of storage in each one of 3 hosts, and you were to use vSAN, you could aggregate that local storage together and create a distributed data store of 30 terabytes. And it would be available for you to run your VMs on that storage. So this is hyper-converged infrastructure. If you add a host to the environment, you add storage, you remove a host, you remove compute and storage as well. The third piece is NSX. This is the network and security virtualization. This is a really powerful technology. It gives you a few different capabilities. One is it gives you the ability to extend networks across layer 3 boundaries. So in a traditional on-premises environment, you probably run into that case where I have a layer 2 network and I want to try to extend it across to another facility or to another location, but I only have a layer 3 network in between those two places, so something like an MPLS connection. But NSX actually gives you the ability to extend layer 2 networks across layer 3 boundaries. It has a ton of other features. It can do things like microsegmentation or distributed firewalling. So functionality very similar to like a security group within AWS. This gives you the capability to actually take two VMs running on the same subnet and restrict the communication from each other. So this lets you do things like present horizontal or lateral movement within an environment if one machine were to be compromised. It can do a lot of other things, such as IPsec VPN termination, typical network services that you would expect in an environment. The other cool thing about NSX is it also has an API, so you're able to automate a lot of the functionality and do things programmatically. So on-prem, if you've ever been in one of these environments to where the virtualization folks would say, okay, we want to set up a new network, so they would cut a ticket over to the networking team would go create VLANs on all the physical switches, they would actually trunk those VLANs back to the physical host, the VMware team would then have to go in and create port groups, define those VLANs, it was all manual, waiting for people to go perform these tasks. With NSX, you can actually make an API call and create a new logical network. Last but not least, there's vSphere. So this is using vCenter, the traditional vCenter environment that you're accustomed to, but ultimately the same management interface, the same control interface that you've been using for years. So a software-defined data center is essentially taking all of these components and using them together. So I'm going to use ESXi for compute virtualization, vSAN for storage, NSX for networking, and vSphere for management. So VMware Cloud and AWS is essentially taking this software-defined data center and delivering it to you as a service. So I log into a console, I click a button, and I say, give me a new software-defined data center. I then have a fully functional VMware environment ready to go in about 80 to 90 minutes. So compare and contrast that to the traditional on-premises experience where you go order hardware, you wait for it to arrive, you eventually get it unboxed and racked and stacked, you burn it in, you install software, you test the software. Sometime within weeks to months later, you actually have an environment ready to go and ready to be used. So this process traditionally takes weeks or months. With VMware Cloud and AWS, you're able to provision a fully functional VMware environment within 80 to 90 minutes. So within VMware Cloud and AWS, we have two different instance types that are available to be used today. So there's i3 Metal and R5 Metal. One thing to know about VMware Cloud and AWS is this is not nested virtualization. This is not vert on vert or some type of trickery. This is ultimately ESXi running directly on bare metal. If you haven't had a chance to check out a session or to read up on the Nitro technology, the Nitro card that we've developed at AWS, I'd highly recommend checking that out. It's amazing technology. And ultimately, that technology is what's enabled us to be able to run ESXi directly on bare metal. So the way this works ultimately is that VMware is able to take these bare metal instances, they can then install their software stack, the full software-defined data center. They have a prescriptive configuration, so they worry about all the configuration of it, and they will essentially deliver that to you as a service. So you no longer have to patch, update, upgrade, deal with any of the management of this vSphere environment. You just say, give me an environment, VMware takes responsibility for managing that. You get to focus on actually running your workloads. The two different instance types that I mentioned here, the i3 Metal and the R5 Metal, a couple of key differences between them that's pretty obvious. I mean, there's some differences in core counts and memory. That's pretty obvious. But the other one is the storage aspect of it. i3s have 15 terabytes of local storage. So VMware takes that, they carve a portion of that up for caching, they use the rest of that for capacity, and they're able to deliver that to you. You end up with somewhere in the neighborhood of 10 terabytes of actual usable storage per host. But this is the hyper-converged infrastructure model to where you're actually using local NVMe-based storage. This is really cool if you think about it, because normally if you talk to an AWS solution architect and you say, hey, I want to actually store persistent data on local instance storages, after they probably black out, they'll come back and say, don't do that, that's a terrible idea. Please don't put persistent data on local instance storage. If that host dies, then your data is gone. But vSAN, since it actually takes that data and handles the resiliency, handles the redundancy of that data, we're able to marry these two technologies together. So you're able to use this local high-performance storage, but also VMware uses vSAN to make that storage resilient and actually stretch the data across multiple clusters. So you get our multiple hosts. So you get high performance of local NVMe all-flash storage, but you get the resiliency with vSAN. The R5 metal instances, the key difference here is this is actually using EBS as an external storage. At the time you provision the cluster, you can ultimately define how much storage you want to have per host. So if you want to have 15 terabytes or 20 terabytes per host, you can define that up front, as opposed to just being stuck with the amount of fixed storage that exists in a host environment. Okay, so we talked about what a software-defined data center is. We've talked about the actual instance types that you can use. We talked about it's running on actual bare metal. Within the software-defined data center, you have the ability to create multiple clusters. Just as in an on-prem environment that you can stand up multiple clusters, you can do the same thing here in VMware Cloud and AWS. So why would you want to create multiple clusters? Well, in one case we just talked about, you have different instance types. So if you need different core counts or memory or different performance characteristics of an i3 versus an R5, you can use one cluster type versus the other. Another case is a lot of customers are stuck with these punitive licensing models to where they need to have lower core counts because they pay licensing based on the number of cores. So customers can take and say, I want a small 3-host cluster just to keep it as small as possible, and I'm going to run this particular type of workload on this cluster to keep my licensing costs down. But for the rest of my workloads, I want to have one large cluster, or I want to have a couple of different clusters there. But this ultimately gives you the ability to create clusters based on your performance needs, licensing needs, those types of things. So we can dynamically scale these clusters. Again, this is the cloud. We have elasticity. So this is all done on a per host basis now. So I can click a button and add a host to an environment or remove a host to an environment. This has a couple different things that I'd like to share with you that really impact the way you should think about capacity planning of VMware environments. One is that traditionally customers will operate their VMware environments like 40% utilization or so. And they do this for a couple of reasons. One is they have to be able to survive host failures. If a host fails, you don't want the rest of your cluster going into degraded state. And the next one is nobody wants the golden VM. I need one more VM, now I have to buy a $20,000 blade. So people leave slack capacity in their clusters to be able to absorb some of the usage and tolerate failures. So in VMware Cloud and AWS, you no longer have to leave as much slack space. And the reason for that is if a host fails, we can dynamically replace that very, very quickly. So if we send a retirement notification to VMware and say, hey, this host has an issue, or if a host fails from the environment, VMware can actually add in another host to the cluster. They make the EC2 run instance command to us. They provision a new host in the environment. They have ESXi running on it. They join it to the cluster. They essentially use vSAN to rebalance the cluster or replicate the data onto that new host. If the other host is still present, if it was just a retirement notification saying, hey, sometime in the next couple weeks this host is going to go down, they can actually put that host into maintenance mode, cleanly evacuate it using vMotion, and have no issue there. So we bring a new host into the cluster, we actually pull the bad host out of the cluster, and we're up and running. So what this means is if you're moving workloads into VMware Cloud and AWS, one of the things that's really important to look at, and something I always tell people to scrutinize heavily, is your consolidation ratios. You can pack a lot more VMs per host in a VMware Cloud and AWS host than what you can traditionally do on-prem, because you're no longer having to leave as much slack space. You don't have to account for that. Likewise, if you need to add capacity, and normally in an on-prem environment, you would bulk buy a whole bunch of hardware so you get the biggest discount possible, and then you grow into that capacity. In this case, you can add capacity in 10 minutes. So you don't have to leave a lot of lead time. So I can run my cluster at 60% utilization, whatever I'm comfortable with or whatever I'm willing to tolerate. And if I need more capacity, I can make an API call, or I can go in and click a button in the console and add that capacity. One other really cool feature that you can do with VMware Cloud and AWS is VMware has taken the elasticity of the cloud and they built onto their DRS capability. They have new functionality called Elastic DRS. Elastic DRS essentially is being able to define thresholds in a cluster on compute, memory, and storage. And say, if you exceed these thresholds, I want you to automatically add a host to a cluster. So you can think of it like auto-scaling, but at a cluster level. So in this case, if you exceed one of those thresholds, VMware will automatically add a host into the environment and rebalance, and DRS will essentially do bin packing and redistribute the VMs across that host. Okay, so we have a SDDC. We have multiple clusters in the environment. Let's talk a bit about networking. Networking and connectivity is one of the biggest parts of having a hybrid cloud architecture. This is huge. If you take nothing else away, please pay attention to the connectivity things that we talk about today. These things are going to be really critical and ultimately why I spend a lot of time talking about them. So in a software-defined data center, they're using NSX. NSX has the concept of these T0 routers and a compute gateway and a management gateway. So the VMs running inside of VMware Cloud and AWS are not connected directly to an underlying VPC subnet. They're actually connected to these overlay networks that exist within VMware. They're called logical networks. And these logical networks essentially need to connect to a gateway to get out. So they're able to connect to the compute gateway and management gateway. Behind the management gateway, you'll see things like the vCenter server appliance, the VCSA. Also, NSX control cluster, NSX manager, the traditional NSX backend components. In an on-prem environment, you typically run a separate management cluster, and you would have a management and a compute cluster. In this case, the management and the compute cluster are consolidated. They all run on the same environment. But we've logically separated the networking. So you have the compute gateway and the management gateway to do that, with the management gateway being the piece for all of the management components. In the compute gateway, I mentioned you can create multiple logical networks. So in this case, we've created 3 logical networks. We have virtual machines running across all of them. I mentioned NSX had distributed firewalling capability earlier. So in this case, if I had 3 VMs running on network C, and I wanted to prevent each one of those VMs from being able to talk to each other, but I wanted them to be able to talk to particular VMs in network B, I could make that configuration happen. The connectivity here is really crucial. So with this T0 router, this is really the internet gateway, the IGW that you would typically see in an environment. So I'm able to do things like use this as my communication point to get between the underlying networks as well as the overlying networks, or the overlay networks. So I can do things like bring in direct connect into a VMware Cloud and AWS environment. I can do L2 VPN, the actual layer 2 VPN, layer 3 VPN. I can also do connectivity through ENI. And I'm going to walk through each one of these pieces separately as we go along, because these are really important to how you actually communicate with VMs running inside of VMware Cloud. An important thing also is that I mentioned you can have multiple clusters within a software-defined data center. I can also have multiple software-defined data centers. So why would you want to have multiple SDDCs? A couple different reasons. One is an SDDC, that T0 router I was just talking about, for every single SDDC, you end up with a separate T0 and CGW and MGW. So if I needed to actually horizontally scale from a scaling perspective, let's say that within one of my software-defined data centers, I'm running 10 clusters, each cluster at 16 hosts. I've essentially reached capacity within that SDDC. That's a lot of traffic to run through a single T0. I could actually create multiple SDDCs. Each one of those would have their own T0s. It's not uncommon to see customers, especially with workloads that produce a lot of packets per second or a lot of throughput, to actually create multiple SDDCs to horizontally scale through those T0 routers. So this gives you another endpoint to terminate IPsec VPN to and those types of things. So horizontal scaling is a common reason to actually do that. The next one is being able to do things like segment across logical business units. So if you have one business unit traditionally operates in a very isolated fashion, you could create separate SDDC for them versus the other. And then like what I've distinguished here is just if you have prod, dev, corporate networks, QA networks, whatever you may have, you could ultimately decide I want these environments to be very siloed from one another and configure them that way. The account structure is a primitive that I really want to make sure everybody understands. This is a question I get asked a lot. Folks will go stand up a VMware Cloud AWS environment, and they're like, hey, wait a minute. I don't actually see the compute resources running in my VPC. Like I'm logging into my console, and I don't see anything. Where are these resources? So VMware Cloud and AWS operates a little differently than what you would traditionally expect an EC2 instance to operate. For one, VMware actually goes off, when you log into their console and you say, I want a new software-defined data center, VMware actually creates a brand new AWS account just for you. So this is single-tenanted. There's not some giant pool of resources that are all shared. VMware creates a brand new AWS account. They create a VPC within that AWS account, and they deploy those resources into that VPC. So it's completely isolated for you, the customer. They then deploy the environment, they configure it, they manage and run and operate that environment, and then they connect it back to your AWS account. So if you think of RDS, if you've ever used RDS, if you fire up an RDS database, you don't actually see the EC2 instances running that database in your AWS account, right? You just see some ENIs pop up in your account, and that's the connectivity you have to those databases. VMware Cloud and AWS operates in the very same way. So all of the resources are running in an account that VMware owns and operates, and it connects back to your AWS account from a network connectivity standpoint. So VMware basically, they get the bill from AWS for all the resources running into that, and then they can bill you, the customer, for the VMware Cloud and AWS service. We're going to talk a lot about the connectivity between the two, but I just wanted to make sure we really focus on the fact that these are two separate accounts and how the account structure actually works. Okay, from a connectivity standpoint, I mentioned that ENI connecting the two accounts together. This is what it really looks like in practice. So on the left-hand side, I have the actual VMware Cloud and AWS SDDC account. This is where those resources are running. So in this case, I have a 4-host cluster. I mentioned that T0 router and the CGW. I've really kind of consolidated those and just called it Edge here for simplicity. And then I have my network A with all the VMs running behind that. Each one of the hosts in this environment will have an ENI that is connected back to your AWS account. Something important to think about here is whenever you go to provision an environment, it asks you which subnet you want to connect your SDDC to. It's important to pay attention to which subnet you choose. And it's kind of obvious when you think about it, but it's not completely obvious up front. The subnet that you connect to will essentially determine where the traffic from your AWS account to that SDDC traverses. So if you pick a subnet in a particular availability zone, but all of your VMs are communicating to a resource in a different availability zone, now you're going to have cross-AZ charges for that traffic, because it's essentially the access point is within a subnet in AZ1A, but all of your resources are in B. So make sure that whenever you choose the subnet you want to attach your SDDC to, that you choose the subnet where most of the resources it'll be communicating with are. That just optimizes from a cost perspective, so you're not getting some unnecessary cross-AZ charges there. So one of the questions that comes up is, well, if I have a 4-host cluster and each host has an ENI, does traffic just get sent to all of the ENIs? How does this ultimately work? So whenever we actually connect these accounts together, you will execute a CloudFormation template. That CloudFormation template creates a cross-account role, a cross-account IAM role within your account, and associates that role to a managed policy that is controlled by AWS. This cross-account role ultimately gives VMware the ability to perform a few actions within your account. Those actions can be completely audited by you. You can see the managed policy. You can see exactly what permissions they have. VMware cannot change those permissions because it is a managed policy, so they are essentially stuck with whatever permissions that are initially defined. Some of the things that they need to do are be able to create and modify ENIs. So for example, if we needed to add a secondary IP address to an ENI, they could do that, but also update the route tables to point to the ENI. So in this case, let's say the CIDR range for network A has been defined. So they update the route table in your AWS account to say, okay, to get to this CIDR range, you need to point to the top ENI, and that's where the traffic will flow. What happens if that host fails, or if we need to perform maintenance on that host? In this case, VMware has vMotion capability. If it's going into maintenance mode, they'll vMotion the CGW and the T0 off to another host. And they'll use that cross-account functionality to update the route table and point that to the correct ENI. So the ENI connectivity it's natively built in. When we talk about jointly engineered service or VMware Cloud being a jointly engineered service, we're not just using a bunch of VPN connections or any kind of quirky stuff. We've actually taken the same technology that we use for things like RDS, and we've built that into VMware Cloud and AWS. So they have native ENI connectivity into your AWS account. This gives you a much higher throughput, much lower latency than other connection mechanisms. Another piece of functionality we have with VMware Cloud and AWS is stretch clustering. And this really comes into play with hybrid applications. And we're going to talk about this quite a bit as we go through. But one of the challenges when you have these hybrid applications is a lot of times these applications weren't built to run in the cloud. You have an application that wasn't designed to be able to run across multiple availability zones. It can't be re-IP'd very easily, or it really cannot be horizontally scaled. So in that case, what do you do with that type of application? How do you address an application that you can't run in multiple AZs? Do you just run it in a single AZ and hope for the best? Well, at AWS, we always say plan for failure, plan to that availability zone is going to have issues, and make sure your applications can run in multiple places. So VMware Cloud actually gives us a really cool capability here to address those types of applications. We can do what's called stretch clustering. So stretch clustering actually will take and deploy hosts in multiple availability zones. So in this case, I have a stretch cluster. My minimum cluster size goes from 3 to 6 because I do have to have resources in 2 different clusters. I can actually stretch that network. I mentioned earlier that NSX gives you the ability to stretch across layer 3 boundaries. Well, each AZ is its own distinct subnet, so those are definitely different layer 3 boundaries. So I can stretch my logical network running in the overlay across multiple availability zones. The ENI connectivity I just mentioned, same thing applies here. I'll have ENIs that are actually connected into one subnet in one AZ, and ENIs connected into a different subnet in a different AZ. The CGW and my T0 and everything exists up at the top. In the event of an issue, vSphere HA can kick in, or they can even do vMotion if they're doing maintenance. But I can ultimately move that T0 router from my normal AZ down to the secondary AZ. In this case, the route tables will be updated, and it will now flow through that secondary AZ. From a storage perspective, this is also a really cool thing with stretch clustering. It's cool that I can now stretch my networks and I can have a consistent network across multiple AZs, but what about the storage? That's honestly one of the most critical parts here. If I lose data in AZ1, I can't lose my entire virtual machine. That's a problem. So VMware actually uses that vSAN technology, and they actually replicate the objects across AZs. They introduced the concept of a fault domain within this environment, so they can define which hosts are sitting in which fault domain. And they will replicate those objects across to hosts running in the other environment. When a VM is actually reading from disks, they do read locality. So if the VM is running in the top AZ there, it's actually doing the reads from the host that the VM is resident on. So it's not having to wait and read across AZs or add latency there. From a write perspective, they do synchronous writes. So I have the performance on the read side from being able to read that data, but I want to make sure that data is protected. I don't want to write it and then have to wait for it to replicate over asynchronously. So in this case, on a write operation, VMware will actually synchronously write that object across to the host running in another AZ. They also have a witness node that they'll set up in a third AZ. So you'll notice that stretch clustering is only available in environments which have a third AZ. And this is so that they actually can have a witness node to deal with network partitions or the split brain type scenario. Okay, let's wrap up some of the basics on VMware Cloud A DBS, and we'll get into the actual hybrid cloud architectures. So SDDCs, we talked about logical grouping. Why would you want to have multiple SDDCs? Being able to group that by business units, logical considerations. Connectivity is a big one. We just talked about that ENI connectivity. I may have an SDDC that I only want to be connected to my production AWS account or accounts. I may want to have an SDDC that is only connected to my corp or development environments. On-prem connectivity, if I have direct connect or VPN access, I may only want to connect those to particular SDDCs and not have access from my QA environments or my development environments. So being able to essentially create multiple SDDCs gives me the ability to segment a business unit as well as networking. Also from a scalability perspective, there's some scalability considerations that may dictate that I should create multiple SDDCs. On the cluster side, I can also create multiple clusters. I can do that because of instance types. Licensing is a huge one there. A lot of folks want to create separate clusters just to handle licensing considerations. But also, I may want to have one cluster that's stretched across multiple AZs for production, for example. And I may want to have another cluster that is just a single AZ environment. I do want to point out you get a higher SLA on the service if you run stretch clustering. And I highly recommend folks look at stretch clustering. It's an awesome capability. And it's also something that gives you a lot of flexibility for applications that aren't traditionally built to deal with multiple AZs. Okay, so a couple months ago, I was talking to a lot of customers, and the conversation on hybrid cloud kept coming up. And so the thing I kept asking people, and it was really interesting, I was like, what are you actually trying to accomplish with a hybrid cloud architecture? Why are you wanting to run hybrid cloud? Interestingly enough, a lot of people didn't know. They're just like, hybrid cloud's a buzzword. I want to go do hybrid cloud. This sounds amazing. But a lot of folks actually had some really interesting feedback, and I started to see some themes emerge as to why people were wanting to do hybrid cloud. And I encourage you to think about, if you're looking at hybrid cloud and you're trying to do a hybrid architecture, what is the actual business outcome you're trying to drive? Why are you trying to ultimately accomplish this? Is it some type of risk aversion type thing? Is there technical functionality you're trying to achieve? Are you sweating assets on premises and you're trying to make sure that those assets are used for a longer period of time? But really think about the business objective that you're trying to accomplish with a hybrid architecture and work backwards from that. I wanted to share some of the themes that I heard from customers that I was talking to. The first one was interesting because it's not really apparent at first, but it's migration. And a lot of people, when I say migration, they're like, wait a minute, I don't want to do a migration, I want to do a hybrid. Why are you talking about migration? And the interesting thing about a migration is that while you're doing the migration, you are operating in a hybrid fashion. You're not snapping your fingers and everything is running up there all at once, typically. And in most cases, this migration is taking a few days at the very best, or maybe even weeks or months at the longest. But while you're operating in this migration, while you have some workloads running in the cloud and some workloads running on-prem, you're actually operating in a hybrid architecture. The next one is workload mobility. Now, this is one that is not quite as prevalent or not quite as popular, but some folks actually were interested in the ability to actually move a VM into the cloud environment and be able to then take that VM and move it back. Some examples I heard were we want to be able to move some of our workloads up there, have them do a bunch of processing while we're doing patching and updating in our on-premises environment. So essentially using it like a lifeboat, moving stuff up there, doing a bunch of physical work in the on-premises environment, and then moving it back. That was actually an interesting use case I hadn't quite thought about, but one that's certainly possible. It seems like a lot of work, but there's some validity there. But having the ability to move those workloads back and forth was another theme that I heard with being able to do a hybrid architecture. The third one, and this was a much more common one, that's not me, was actually being able to supplement capacity from an on-premises environment. And this actually really makes sense if you think about it. I have a certain amount of capacity on premises. I may not want to necessarily go add more hosts just to run something that's temporary. So if my fourth quarter gets really huge, I may want to be able to burst into the cloud, essentially, add additional resources in the cloud environment, consume those resources when I need them, turn them off when I don't, continue running in my on-premises environment. So this is a case actually where when Nick was here, he was talking about a use case they have with VDI. We'll actually talk about that here in a few minutes. But being able to supplement your on-premises capacity with cloud resources. And lastly was augmentation. And this was really an interesting one as well, is wanting to take advantage of some of the capabilities that we had in the cloud to augment the capabilities that they already had on premises. And so this is using native AWS resources, but also just being able to move those resources to different locations depending on their needs. We'll talk about data gravity, and this is actually an interesting one of why I would want to move my database into a separate location for my applications or even different capabilities within that. If you think about from a microservices perspective, typically you have different functions of the applications that are segmented off, and all of those functions may not necessarily be running in the same location. I could have some aspects of a distributed architecture running in my on-premises environment. I could have some running in VMware Cloud. I could have some running in AWS. And really, those are the kind of the triangle, if you want to visually picture this, is I have on-prem, VMware Cloud, and AWS, and then my native AWS accounts. I could have a combination of those three endpoints ultimately running my resources. And how do I connect those things together? How do I determine where I run resources? How do I choose which is the best home for various aspects of my workload? So I wanted, when I was thinking about how to convey this, really the way I came up with this, I wanted to put some diagrams up here and walk you through examples of things you could do, as well as examples of things that have been done, and give you just real practical uses of these various use cases and various architectures. So let's talk about that migration one first. In this particular case, I have the triangle that we just talked about. I have my on-prem environment, I have my VMware Cloud and AWS SDDC, and I have my customer AWS account. I have an application and a database that are running in my on-premises environment. I have resources that are running inside of AWS. In this case, when I started off, I made the comment, you can do a lot of stuff with your on-premises environment with native AWS services. You don't necessarily have to move things into VMware Cloud on AWS, but there's advantages to doing so. This is an example of that. So when I talk about being able to run against on-premises, if you haven't used AWS Glue is a really cool service. It allows you to actually go out and discover data, extract data, do transformation and load. So you can do ETL jobs basically through this. In this case, I have a Postgres database running on-prem. And I want to be able to actually do some additional stuff with this. I want to get analytics and do additional things with this data that's running in my on-premises Postgres database. So in this case, I've used AWS Glue. I've gone and I've pulled this data out of my on-premises Postgres database. I've done some transformation. So in this case, I'm transforming that data into more of a CSV style format, and I'm dumping that into an Amazon S3 bucket. So I'm pulling data from on-prem, transforming it, and dumping it into an S3 bucket. I can then take that data from the S3 bucket and actually pull it into Redshift and do analytics on that. So in this case, I've not moved anything. I'm still running on-prem. I have a hybrid configuration here, and I'm pulling data from on-prem into S3 and then ultimately into Redshift. And in this case, I'm just using a layer 3 VPN connection. So nothing fancy. Build a VPN connection, configure the AWS Glue job, pull the data, and then run analytics on it. Pretty simple configuration here. I didn't have to move anything. I didn't have to do anything crazy. In this case, what if my database starts getting huge? What if it's a lot of data? Pulling that data all the way across the VPN every single day or however fast I'm running this job, I may have to increase my circuits or maybe it's just taking a long time for this job to complete. Data has gravity, and the gravity in this case is centered in my on-premises environment, which makes it really difficult for me to do a lot of the other things that I may want to do from an analytics side in the cloud. So in this case, I spin up a VMware Cloud and AWS environment. I mentioned earlier, I can fire this up pretty quickly. VMware has the technology called HCX, the hybrid cloud extension. HCX is really awesome. It does a couple different things. It's an orchestrator that allows you to actually orchestrate migrations of workloads to the cloud. Just a quick side note for HCX, and this is a VMware product, not an AWS one, so I'm not trying to sell anybody on it, but I've seen customers do really amazing things here. It takes a little work to set up. It's a little bit of a lift to get it up and running. Once you get it up and running, it is super easy to actually migrate workloads into the cloud environment. I've had customers tell me they go in and configure a job in HCX, they go home for the night, and they come back the next morning, and hundreds of workloads have moved over automatically. They didn't actually have to touch anything. Besides just orchestrating this, HCX also has the capability to extend layer 2 networks. So it actually builds a layer 2 VPN from your on-premises environment into VMware Cloud. This lets you actually move workloads without having to do any IP address changes. So I've extended that network between my on-prem and the cloud environment, enabling a more seamless migration. One caveat I do want to point out, I always like to try to point out the considerations or the tough points or things you really need to think about, is when you extend a layer 2 network from your on-premises environment into the cloud, the default gateway has to exist in one place or the other. So in this case, if my default gateway is on-prem and I've moved the resource to the cloud and I'm trying to get over to my AWS resources, I'm still going back on-prem and then coming back through that layer 3 connection. So at some point you can choose wherever in the migration you want to actually kick over that gateway and move it to the cloud environment so that I'm now ingressing and egressing that subnet in the cloud environment. So something to think about if you decide to do a layer 2 extension, figure out when in the migration you're actually going to kick over that default gateway so that you're egressing from that correct point. So in this case, through the magic of PowerPoint, we have now migrated a VM from on-prem into the cloud. Was that not the easiest migration you guys have ever seen, right? So we've migrated the application and the database into the VMware Cloud and AWS environment. We can now leverage that ENI connectivity I talked about, and now when Glue goes to pull that data from my database, it's happening much faster, right? This is going across an ENI versus going across a VPN connection over the internet. So this is a case where I was able to do the same thing on-prem. It was completely possible and functional, but I could actually leverage HCX, pretty easily migrate the VM from on-prem into the cloud environment, and then leverage that native connectivity between the SDDC and my VPC to be able to perform that job much, much faster. So this is a case from PennyMac where Nick actually had a very similar situation. What they ended up doing is they ended up migrating their application into VMware Cloud and AWS. They had a third-party application, so this was an interesting case to where they didn't actually have the ability to modify the code. This was a virtual appliance that they essentially just deployed into their environment. What they did have the ability to do was define a database, an external database from the virtual appliance. And in this case, they had put the database onto a shared database server, which is a pretty common practice on-prem, right? You paid a lot of money for these SQL licenses, so you're going to throw a lot of databases onto a single cluster or single server. And in this case, they were actually running into performance problems with that database. They had so many databases packed into it that it was causing performance problems for them. So they actually, because it was a third-party application, it wasn't quite as easy to take that virtual appliance and move it into native AWS. So they actually moved that virtual appliance into VMware Cloud and AWS, but when they did that, they took the actual SQL database and moved that into RDS. And so now the database is running on its own RDS environment. They gained the ability to have it be a managed service, so now they're no longer having to actually deal with the database itself. So here's another hybrid architecture to where, in the kind of the migration umbrella, to where I've moved the application into VMware Cloud, but the database is now running in native AWS. On the supplemental capacity side, here's another example. This is just something you can actually do. I don't know that a lot of people really think about this, but it's a great use case. You can actually use CloudWatch Logs from your on-premises environment. So if I have a couple of VMs running on-prem, I can actually install the CloudWatch agent on those VMs and have them send their logs into CloudWatch Logs running in AWS. One of the cool things you can do once you have the data in CloudWatch is you can trigger events based on that data. I've seen customers do pretty interesting things to where, for example, on login, if they want to say, I've detected a login event, they can actually go perform a whole bunch of different events in the background from a security perspective. Was that login authorized at a particular time, or was it expected? Did somebody log in when they shouldn't have? I mean, there's a lot of other tools to do those types of things, but also just basic security assessments as well. I saw an error in a log. I want to go trigger a bunch of activities to automatically check on things. But it's pretty easy to actually just install the CloudWatch Logs agent on a VM in your on-premises environment. And that can actually talk to a VPC endpoint. It's not having to talk to a public endpoint. CloudWatch Logs has a VPC endpoint, and you can actually configure that to be leveraged across, in this case, a direct connect. Another thing, too, I've seen people do is I don't want to install a CloudWatch agent in my on-prem environment. One thing you can do is actually install CloudWatch Logs agent on your syslog server and then be able to then take the logs from a syslog and dump that into your cloud environment and then trigger events on that. But it's relatively easy. We actually have done this in some of our labs in the workshops this week, is installing CloudWatch Logs agent, sending that in, and then triggering Lambda functions based on events that you detect. The same thing holds true here. If I needed to ultimately add capacity, I have these VMs running on-prem. I want to be able to augment that capacity. I can actually programmatically spin up an SDDC. We mentioned earlier that all of these things can be done via an API. I could spin up an additional SDDC. I can actually drop a VIF into this account for Direct Connect. So in this case, if I have a VIF already, I have a Direct Connect circuit set up, I've dropped a virtual interface into my VPC, and that's my normal operating model, I can actually drop an additional VIF into my SDDC and leverage that Direct Connect not only for connectivity to my AWS accounts, but also for connectivity into my SDDC. So in this case, I've stood up an SDDC, I've dropped a VIF into that environment, and I have connectivity between all three endpoints now on my triangle here, my on-prem, my SDDC, as well as my VPCs. I can then spin up additional VMs. Again, programmatically using the vSphere API, I can spin up 100 VMs, 200 VMs, 1,000 VMs, whatever I need ultimately to supplement my on-premises capacity. And since it's running in the VPC, I can now use that ENI connectivity to actually communicate to the VPC endpoint I have in my AWS account. So again, the same thing I could do from an on-premises basis, I could also do when running in my VMware Cloud environment. But in this case, I have the ability to scale not only at a host level, but I can add VMs. If I no longer need this capacity, cool, tear down the SDDC, tear down the VMs. I no longer need it, go back to operating in my on-prem environment just like normal. So where this became real from a PennyMac perspective is PennyMac actually took this from a VDI perspective. So interesting thing about their business is as the interest rate would change, the federal interest rate would change, they did loan origination and they would actually get a lot more business as the interest rate would lower because more people were applying for mortgages and loans. So cool thing that they ended up doing is when the interest rate would drop, they came in saying, we need to hire hundreds of more people. How long is it going to take us to actually be able to get the infrastructure to support hundreds of more employees? And this is pretty important to their business. They can capture additional business if they're able to scale and have that agility and move quickly. So in their case, they actually had VDI environments running on premises, and they would have their loan agents that would be working in these VDI environments. And they needed to be able to scale super fast, so they deployed an SDDC. In the SDDC, they actually used Horizon, and they were able to deploy a ton of VMs for virtual desktops for these loan agents, and they were able to do that very, very quickly. And these loan agents are essentially using other services that are running within native AWS. So they had web applications and Active Directory, various things that were running natively within AWS. So because they had that VPC connectivity, they were able to quickly spin up. This ultimately allowed them to move super fast, and they were able to bring on hundreds of additional users in less than a month and have them fully functional, ready to go. Okay, augmentation perspective. This is probably the thing that a lot of people are looking to do, an area that I see a lot of people really asking detailed questions on. So I was thinking of an example. I was like, how can I actually make this real for people? And one of the examples that I was thinking about was on the insurance side. If you think about an insurance company, normal policy management, I have new policies, renewing policies, those types of things, that's all pretty steady state usage, right? You don't see just massive amounts of variability in the time of year or things like that when people are renewing policies. Where insurance companies really have huge spikes in usage is when there's a large natural disaster. So think a hurricane or an earthquake, a wildfire, something like that, where a lot of people are having to get information about their policies or also file claims. And this is a case to where it can be really tricky because insurance carriers also typically have mainframes. They typically use a lot of mainframe type environments. They have tons of databases, tons of third-party applications to do everything from actuarial things to claim photos to being able to have policy documents generated. They have tons of third-party applications, tons of different databases, as well as mainframes in their environment. So this is a pretty tricky environment to be able to scale. So taking that model and applying it to this augmentation umbrella, let's say that we have an insurance company that actually has an event and they need to scale pretty massively pretty quickly. So on the front end side, they could take their web front end and they could use things like Route 53, CloudFront, and WAF. So these are just traditional edge scaling mechanisms. We're going to use application load balancer. We're going to scale the web front ends and we're going to point all those to EC2 instances. So my web front ends are running in EC2, application load balancer, all of the traditional CloudFront scaling approaches that we're doing here. Great, now we can absorb the onslaught of users that are connecting into us, right? But I don't want to have to go back to my on-premises database with a lot of this communication that's latency. So I can bring some of these important databases into my cloud environment. I can run them in RDS where I can actually scale these and offload that work of absorbing that. I could use things like Redis or Memcached and within Elasticache to be able to actually cache some of these things, really improve performance there. And then leverage things like Redshift for being able to do analytics. So now I've been able to offload a lot of the front end pieces into the cloud environment. But because I have the communication with Direct Connect, I can also be able to communicate back to my on-premises mainframe, the applications and the databases. I mentioned also third-party applications. Again, another great use case if I have a virtual appliance that doesn't easily transform into a native VPC. I can move that virtual appliance, that third-party application, some of those databases up into VMware Cloud and AWS. But ultimately, I have communication between all of these environments. So I've literally taken a single workload, this claims workload. I have front end running inside of native AWS. I have the mainframe back-end components still running on-prem. I have my third-party applications running in VMware Cloud and AWS. But ultimately, I can take whatever the best use case, where's the best place for this thing to live, and I can make that work in this particular scenario. So all these diagrams I've showed, one of the interesting things is they're all pretty simple, right? It's just like one VPC, very clean. The reality is most customers don't operate one VPC. And knowing that, I really wanted to show, again, being more real here, how does this actually impact you? If you have multiple AWS accounts, if you have multiple VPCs, connectivity is a challenge. The ENI connectivity is great. That gives you that high throughput, low latency connectivity. Direct Connect is great. The VPN connections are awesome if I could do things like layer 2 stretch. That gives me capability to be able to quickly migrate and move workloads to the cloud. But it can also get really complex. Nick was telling me on the PennyMac side, at one point they had over 30 VPN tunnels running in their environment. This is a real pain to manage. It can be a bit of an overhead for them. So one of the things that they did is they ended up using Transit Gateway, and they connected all of their VPCs into the Transit Gateway. This is something that we've seen. If you haven't already taken a look at Transit Gateway, please do so. I've seen customers really simplify their architectures and really do a lot of cool things with Transit Gateway. And one of the cool things here is you can actually use Transit Gateway to connect into your VMware Cloud and AWS SDDC for communication between your SDDC and VPCs. So we still have that ENI connectivity at the top, right? We can see T0 to ENI in the top VPC. I see a lot of customers use this for connectivity to VPCs that have just tons of data transfer, but also if they have shared services VPCs. So common things were like Active Directory, their logging infrastructure, a lot of their Bastion hosts or things that they're using in that form. They'll connect their SDDC up that way. And then they'll use the transit gateway to actually connect to all of their other VPCs. Now, the transit gateway integration is going to be through L3 VPN into the SDDC. So I can build a VPN tunnel from my SDDC into transit gateway, and that will facilitate connectivity out to all of my other VPCs. One of the things I have seen customers try to do, and it's possible, but it's not something we recommend, is they try to actually connect the on-premises environment in through transit gateway and use that for communication into the SDDC. Now, this will work for moderate workloads, for pretty minor workloads. But when you do things like vMotioning or you're replicating tons of data, that's a lot of traffic to be sending through this VPN connection through the transit gateway. Most of the VPN connections are around 1.25 gigs, so it's a lot of flows to go through that. Still highly recommend that if you're going to do connectivity from your on-prem environment into the SDDC, look at using Direct Connect to drop a VIF straight into that environment. Do the L2 VPN or the L3 VPN directly into the SDDC. You're going to get much better performance that way. You're going to have a much more stable connection. It is possible to go through the transit gateway, and that really helps for communication to the VPCs and the AWS environment, but not something we'd recommend for communicating back from on-prem into the SDDC. So this hopefully will help you see how you can simplify your communication. So connect your on-prem to the transit gateway, use that to communicate to all your VPCs. Connect your SDDC to transit gateway, use that to communicate between the SDDC and all of your VPCs, and still use that communication between your on-prem environment and your SDDC directly for things like vMotion and SRM replication and those types of things. All right, so I've alluded to this question a few different times, and this is a question I get asked a lot is, okay, I have this cloud strategy. I'm trying to reconcile the capabilities of VMware Cloud and AWS with the capabilities of native AWS. When should I move a workload to VMware Cloud and AWS versus moving it to native AWS? How do I choose between the 3 endpoints in this triangle? Where do I run my workloads? Give me some guidance, give me some prescriptive advice on how I do that. And it's really, it's not that complicated of a question. There's a lot of different considerations there, and I wanted to try to share some of those with you. This is a case where I had a build slide where I really didn't want one. So the first one is from a security perspective. Are there things that you're trying to do from a security perspective that are better suited in native AWS or better suited in VMware Cloud? We can do a lot of the same things. So there's distributed firewalling within VMware Cloud. There's security groups within AWS. One example that comes up is if you're using IAM instance roles. So if you wanted to be able to actually have an EC2 instance, have an IAM role associated to it, and that handle the actual secrets management for authenticating to other native AWS services, that may be a case where you want to actually leverage a native EC2 instance. On the flip side, if you have an application that is a third-party application that you don't actually own the code, you can't modify that code to take advantage of a lot of stuff within the native AWS side, that may be a better case to run it within VMware Cloud. Also, you can do things in VMware Cloud that you can't do in AWS natively and vice versa. So this is really just to think of it as a tool in your toolbox and figure out which is the best tool for this particular job. A couple of examples of things you may want to run inside of VMware Cloud for. If you need a custom VM geometry, so what I mean by that is saying, I want 1 vCPU, but I want 16 gigs of RAM. Well, we don't have an AWS instance that meets that particular form factor. So if you need a high number of vCPUs, low memory, or vice versa, or you need a very explicit configuration of VM geometry, you can do that within VMware Cloud, and that may be a better fit for running than in native EC2. Likewise, if you have some custom x86 operating system, some type of virtual appliance that is not running a traditional AWS instance. I've also had people say, hey, can I run like a Windows 7 desktop? And while that's not supported in the VMware environment as well, you can run Windows 7 in that. So there's different use cases to where running something inside of VMware Cloud may make more sense than running in native AWS. Whereas in AWS, if you want to do things like IAM instance roles, or you want to add things into auto-scaling groups, those types of cases, it may be better to run those in native AWS. Ultimately, they're just tools in a toolbox. You have different capabilities within each one of those tools, figuring out the one that works best for you. Another one is data gravity. So this is a case, we showed this earlier, right? I have this huge database. I would like to be able to do analytics. Maybe I want to be able to do some additional things within native AWS services like transcribe or Poly or whatever it may be. I want to leverage all these services. If all of my data is sitting on-prem, maybe it's not as easy to do those things by having to drag it across the wire. In that case, it may be much better to actually move that into VMware Cloud and AWS and then augment those applications to run natively, to use native AWS services. Latency is a big one. This is an interesting case. When I see a lot of people go through migrations, they don't really factor in what latency is going to do to that application. There's a lot of gremlins in code out there that all of a sudden, if you go from 1 millisecond latency to 13 milliseconds of latency, you would think, okay, that's not the end of the world. It's still pretty good latency. And then the application just completely loses its mind. So in this case, latency actually does make a difference. And that's one of the cases of determining, should I continue to run that on-prem, should I run that in VMware Cloud, or should I run that in native AWS? Connectivity, we already talked about that quite a bit. But how am I going to connect this? If I have really terrible circuits in a location, a really low bandwidth area, there's places where I've had customers tell me, it would take me 6 months to get more connectivity into this location if it's possible at all. But ultimately, I don't want to go through that expense. Like, that connectivity is fine for the vast majority of my use cases. Being able to move that into native AWS or even VMware Cloud AWS may be more advantageous there. Tooling, this is also a pretty big one. I have a ton of customers tell me, look, we've built a lot of PowerShell. We have years and years worth of scripting and automation and tooling that we've built around the vSphere API. We don't want to have to rewrite that tooling. We don't want to have to recreate all of that. That may be a case where VMware Cloud and AWS is useful. I have other customers who have both, right? They're like, we've invested a lot in our cloud automation side. We have a lot of Terraform or CloudFormation. We want to be able to leverage that, but we don't want to have to rebuild all of the other PowerShell stuff. We want to be able to use both. So thinking about how you're automating things and the tooling you have behind that is a big deal. And on the management side as well, again, people have spent years, decades of their lives building up skills in certain areas. The shock of having to go from managing a VMware and a vSphere-based environment to one of running it in native EC2, that takes time to learn, right? It takes time to build up those skills and to get that muscle memory. So in some cases, it may be easier to move into VMware Cloud and AWS where you have that consistent management infrastructure while they're still learning native AWS services. Again, this is a very common use case we hear, folks, is I have a ton of applications that I want to continue to operate in VMware. I'm doing a lot of net new development inside of native AWS, but it's going to take my team time to really up their skills on the native AWS side. And I want them to not just be kind of thrown into this super deep. I need them to be able to continue to operate as well as learn the new stuff as well. The last one is availability. We talked about stretch clustering. We talked about the capabilities within native AWS with like auto-scaling groups and those types of things. But look at what is the application availability requirements that you have. Do you need to, whenever you move to the cloud, do you have applications that are going to have to be rewritten or modified to be able to actually run across multiple availability zones? Do you want to invest that time in doing that? If you do and you're refactoring or working that application, great. If this is potentially an application that you're not wanting to invest that amount of time in, or it's a third-party application, then you do have new capabilities within VMware Cloud and AWS, which could potentially help you out there. Okay, some additional resources. I wanted to highlight the reference architectures. My team has spent a lot of time producing reference architectures and publishing these. All of the reference architectures we build are based on what we've seen customers actually doing and queries that customers have actually had. So we've tried to focus on things that are really relevant, like Active Directory and Oracle and things that people are actually doing in the field, and provide reference architectures that will help you get up to speed pretty quickly. All of our reference architectures will cover one of the common use cases that we've talked about, whether it's a migration or a hybrid configuration. We have disaster recovery as well, but also being able to integrate with native AWS services. We tried to illustrate how you would take all of this and not just move to VMware Cloud, but also to integrate with native AWS services within these environments. One thing I also wanted to point out is the best way to figure out how a lot of this stuff works is to actually build something and get your hands on with this. We have the capability to deploy a single host cluster in VMware Cloud and AWS. This is not for production use. Please do not use it for production use. These are essentially local storage on a single host. If that host dies, all the data goes away. So I can't stress this enough. Please do not put important data on these single host clusters. They're meant as kind of a pilot light or a learning point to jump into to test. But we have a lot of customers who will spin up a single host cluster. They'll actually replicate some of their environments into it. They'll test. They'll see the performance capabilities. They'll actually test the integrations that we talked about, figure out the connectivity, get all of that stuff working, see how it goes. And then they can go from a single host into a 3-host or multi-host cluster. So definitely a good mechanism there to check out. with that, we finished with a minute left. So thank you guys so much. Really appreciate you taking the time to come up here in the morning. Thank you. One thing, again, please, 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 I read every single piece of feedback that people put in. If there's something that you liked, didn't like, something you would like to see next year, please give me that feedback. It is very valuable, and I greatly appreciate it. So thank you guys so much. I hope you have a great rest of the day and safe travels back home.